Hello, I'm Dr. David Kordowitz and welcome to Programming. Today we're going to be discussing arrays, which is an extension of variables which we discussed in the last video. The variables that we discussed in the previous video can only hold a single value, where arrays allow us to store multiple values within the same variable. Let's begin. So previously we had talked about declaring variables by simply putting a data type and a name for the variable. So for example, int x can hold a single integer or a counting number that doesn't have any floating point decimal spaces. We said that you could think about this like a box. So basically when I say int x, I'm creating a box called x that can contain a single integer. If you remember, this box will now contain probably garbage that is unusable, so you must initialize the variable before you can use it by setting it equal to something. Now, in a lot of cases, we have devices or sensors or information that we have multiple data points at the same time, or we would like to log data over a period of time. So in other words, continue to collect data and store it so that we can look at it later. To do this, arrays are ideal. To declare an array, we simply add an element that tells us how many boxes we want. So we put this in square brackets. So int x square bracket 5 square bracket will create an array with 5 boxes or 5 elements. Now it's important to note here that this 5 must be a whole number in the case that we're discussing now. There is something called dynamic memory allocation that allows us to declare a variable number of elements. However, that is beyond the scope of this lecture. So this int x5 will create us 5 boxes, which can be seen here. Each of those can contain an integer. So in other words, unlike our previous designation that can only hold a single integer, we can now hold 5. So the first box is exactly the same as x. So in other words, when we declare an array, our first box x is going to be x. Our next box is going to be located one memory location past x. So it will be x plus 1. The next box will be at x plus 2, x plus 3, x plus 4. These boxes, the first box will be the same as x. So we are going to call it x. So this is going to be our first box, which is a single integer value. Now, the next box along the line is going to be located at the next memory location past x, or what we can call x plus 1. Subsequent boxes are going to be at x plus 2, x plus 3, x plus 4, and this allows us to know that all this memory is blocked contiguously, so going from one box to the next is not a very difficult thing to do. That said, it can be cumbersome to remember to add the distances to the boxes. So we can use array notation. In array notation, we simply say x of 0, and that's equal to the 0th box or the first box. Fair warning, when we get into MATLAB later in this course, MATLAB actually labels the first box as 1. So be aware that this is an inconsistency between the languages. As we continue through, the next one will be x1, x2, x3, x4, and so on and so forth. So today we're going to go ahead and use our Circuit Playground Express to develop a simple program. This program will take in data from the 2 push buttons on the board and the slider and store them in an array and display them together. Today we're going to be using the Pinout Sheet, which is available from Adafruit for the Circuit Playground Express. This sheet gives you information about the locations of each device on the Adafruit Circuit Playground Express. What's important to note here is not only the ports that they're on, but also what they're connected to. So, for example, if we're going to be using the buttons, button A is going to be located on pin 4, which we can see all the way over here on the right, but it's also telling you that it is going to be physically at 41 on the chip. This is going to give you information about ports and other things like that. Because it's in purple, it's going to be a binary value either on or off. This is telling you this because it is a digital I/O pin. The slider is on 7, so we need 4, 5, and 7 for our program. We're going to begin with a new sketch. This contains a setup and a loop with nothing in them. The first thing we need to do is set up our pin labels. We're going to do this to simplify things so that if in the future we decided to use a different board or a different layout, we can simply just change the labels and not have to figure out within our program what everything does. To do this, we're going to be using the #define keyword, as we've discussed previously. So simply type #define and then the label, so for example button A, and then what value we want that to have. Now, for those of you who are interested, the #define keyword will use the preprocessor, which scans your code for symbols and replace everywhere that the letter BA occurs with the number 4 before your computer actually processes the value. Therefore, this is acceptable anywhere that you require a whole number. We can do this again for other variables, so such as button B, which we know is on 5, and our slider, which is on pin 7. So now we can use those throughout our program because they're defined as preprocessor declarations. The next thing we need to do is define our ports. So for the purposes of this project, we need to make sure that the computer or the Arduino agree that BA, BB, and SLD are all inputs. To do this, we're going to use pin mode. And we're going to say BA, and we're going to set that to input. We repeat this for the other inputs. We now have all of our inputs set up as inputs, and we can now start using them. Now, for the purposes of this program, we want to have the serial system up and running so that we can display to the screen. We'll talk about other ways of display at later times throughout this course. However, for now, we want to use our serial monitor. So again, we need serial.begin, and we're going to use 9600 as this seems to be the default. And we're going to add the while not serial and put the semicolon on the end. Again, this while not serial is there for the purposes of basically making sure that the serial port is open and functional prior to the execution of the code. Now we're going to go ahead and create a 3-element array here in the loop. Now this is sort of a naive or basic way of using the array, but there are more complicated ways that work even better than this. So we're going to start by saying Boolean let's call it data, DTA, by 3. So this is going to create a 3-element array. This array is where we're going to store our 3 values. So we can say, okay, well, DTA0 equals digital read, and we want to read off BA. DTA1 is equal digital read, and that's BB. DTA2 is an equal digital read B or SLD. Okay, so there are automated ways to do this where you won't need to actually type all of this out. However, we need to be at the point where we know that we're working on loops to be able to do this manually or automatically as it is. So now we're going to use the serial to print out our values. So we can say serial.print, and we need to print out DTA0, and then we're going to do serial.print. And at this point, we're going to use quotes because we're going to put text out. So quote space, comma space. And then we're going to do serial print. And that's going to be DTA1. And then we're going to add a serial dot print. Once we cover loops, this is much easier to do. And then we're going to do a serial dot print line of DTA2. Now, to make things a little easier to see what's going on, we're going to add a little bit of a delay in here. Delay, and let's make it somewhere around 25 milliseconds. That'll give it enough time so that you can see things on the screen without them sort of running off the edge. So we're going to go ahead and write this out to our Circuit Playground Express simply by pushing the right arrow. This will take a moment to compile and get loaded onto hardware. And now we will open the serial monitor. At this point we have 0, 0, 0. I'm going to go to the board and press the A button. You now see that it turned to 1. If I release it, it should go back to 0. Note there's a little bit of a delay there, and that's mostly due to the speed of transmission across the serial port. If I click the B button, there we go. So the second one is 0. If I then go ahead and click the A button at the same time, I've got 2 1s and a 0. Now, if I release both and I switch the slider, we see that the numbers don't change. This is because in the case of a slider, it needs what we call a pull-up resistor. To fix this, we simply go back to our code and we go to the pin mode slider, and instead of input, we're going to add input underscore pull up. This is going to tell it that we need to be pulled up in order to make things work. We're going to go ahead and rewrite our code to the board, and now our slider should work correctly. If you see, it's equal to 1 now, and if I flip the slider back, it should go back to 0. So I'd like to thank you for your time today, and see you next time.